Hello everyone, welcome to Reactify Labs. Today we will discuss a very important question called what are design patterns? Hmm? So in LLD we discuss about design patterns, creational design patterns, structural design patterns, behavioral design patterns, and subcategories of those as well, like singleton, factory, flyweight, facade, proxy. So what are these design patterns actually? Hmm? I have made videos on each of these design patterns, but I realized that I have not answered a fundamental question about design patterns. What are design patterns? Why do we need design patterns? What is something that design patterns are doing that um, we were not able to do without it? So, in short, if I have to tell you, design patterns are basically um, kind of like solutions or template to solve a specific problem. Template to solve a specific problem. Hmm? For example, to help you relate to this, let me explain with a very um, familiar analogy that you might have studied during your maybe 11th, 12th or engineering also. So, for example, let's say you have a rectangle. Hmm. You have to find the area of rectangle. Okay. So, you know the formula, right? Length into breadth. Similarly, you have a square. You have to find the area. Again, for this, you know it's side square. If side is of size a, then it's a square. Now let's say if you have, let's say, a shape like this, hmm? And if you have to find an area for this, how will you calculate it? You don't know, right? Maybe we can do it using integration. hmm? In integration we studied this, right? So we will take a very small strip and then we will integrate it from this end to this end, and that's what we do. So basically the fundamental difference here, if you see, here we could just multiply something. Okay, we could just multiply two numbers and we got our area. But now the shape changed, we have to apply a completely different pattern, or you can say a concept, to calculate its area. We had to create a separate branch of mathematics called integration, or basically calculus, to calculate this area, right? I know it's too complicated, which I'm saying, but basically, this is the easiest way that I could think of to explain this. So, depending on what the problem is, your solution will change. Your approach to solving that problem will change. That's what design patterns also do. So, for example, let's say if you have, let's say if you have to make a video game in which there would be shooting game. Okay, there would be multiple bullets, right? So if you have multiple bullets, like in one game, if you play for 1 hour, you shoot millions of bullets. So for creating an object in game, everything is an object, right? Because it's computer science, everything is an object. So each bullet is going to consume some memory, right? So millions of bullets are going to consume too much memory, like maybe GBs. Hmm? The memory may go in GBs and the game may hang. So we have a design pattern to solve this kind of problem. Similarly, let's say if we have to make a, let's say, chess game. Hmm? So in chess game, what happens is, throughout the entire duration of the game, the chess board will have a single instance. Hmm? So how to take care of this? That there will be only a single instance. For that, again, we have another design pattern called singleton design pattern. By the way, for this, the design pattern that is there is flyweight. Hmm? So that's it, right? So similarly, let's say if we have another problem, for example, if we have to create a family of objects, create a family of objects. So for that, we have another design pattern called factory. So depending on our use case, we have a design pattern. Similarly, depending on our use case, if the structure, if the area or if the shape is straightforward, then we had a different pattern to find that area. But if it's curve, we have a different pattern to find the area. Similarly, depending on the different kind of problem that we are facing while developing software, we have a design pattern to tackle each of them. So that's why design patterns are essential. Okay, now that we know this, you have a high level overview, a good idea. I believe I have clarified myself. I have made it very clear why we need design pattern, because there are different kinds of problems existing. Similarly, let's say you have worked very hard and made a human object, okay, in your system, and now you have to make something similar, exact replica of this. What do? Again, you will write that much code, or you will just write a clone function, which is basically again a prototype design pattern. So depending on the design pattern, depending on your problem, a design pattern is used. Okay, so I cannot emphasize it any more than this, that for each kind of problem there is a design pattern existing. Hmm. And again, it is not very different from this concept. For each kind of area, you have a different concept to calculate its area. Actually, sorry, for each kind of shape, you have a different concept to calculate its area. So similarly, similar to that, we have a different concept or a different pattern for solving each kind of a development problem. Okay, so that's why design patterns are required. Okay, so now that we know why design patterns are required, let's see some of the technical and formal definitions of it. So what are design patterns? Design patterns are reusable solutions. Design patterns are reusable solutions to common problems. As I mentioned before, common problems encountered in software design. Encountered in software design. So they provide a template for how to solve a problem in a way that can be adapted to different situations. Design patterns help in creating more maintainable, scalable, and flexible software systems by applying proven best practices. Okay. So basically, again, if let's say you have written your piece of code here, this code should be maintainable, this code should be scalable, this code should be flexible, right? So our code must follow a lot of things, because as your system keeps growing, the code base will only become large. So it's not like you will spend hours trying to debug the code, right? Or if you have to make a small change, you have to make it at thousands of places, right? So for that, to encounter all those things, to handle all those problems, design patterns come into picture. Okay. Now, basically, a design pattern is a general reusable solution to a commonly occurring problem within a given context in software design. Okay, it's not a finished design that can be transformed directly into code, but rather a description or template for how to solve a problem. Okay, so what is the purpose? Purpose of design patterns. First is reusability. Design patterns provide solutions that can be applied in multiple contexts, reducing the need to reinvent the wheel. Next is communication. They serve as a common language for developers to discuss solutions to design problems. And flexibility. Design patterns promote the creation of flexible and adaptable software designs. Okay. Now let's see the types of design patterns. So first one is creational. Second is behavioral. And third is structural. So creational design patterns deal with object creation mechanisms. Okay, so they deal with object creation mechanisms, how objects will be created. So they try to create objects in a manner suitable to the situation. They help in managing object creation and ensure that objects are created in a controlled manner. And the examples of creational design patterns are singleton, factory method, abstract factory, builder, and prototype. If I have to quickly go over it, I would say singleton design pattern ensures that a class has only one instance and provides a global point of access to it. Hmm? For example, a configuration manager in an application that is shared across different modules and needs to be instantiated only once. Factory method defines an interface for creating an object but lets subclass alter the type of objects that will be created. For example, a dialog box that can create different types of buttons like OK button, cancel button, depending on the operating system. Abstract Factory provides an interface for creating families of related or dependent objects without specifying their concrete classes. For example, a user interface toolkit that can create different styles of buttons and windows depending on the operating system or theme. Builder pattern separates the construction of a complex object from its representation, allowing the same construction process to create different representations. For example, a meal ordering system where a meal can be built with different combinations of courses, drinks, and side dishes. And prototype pattern creates new objects by copying an existing object known as a prototype rather than creating new instances from scratch. For example, an image editor that can duplicate existing images and modify them rather than creating new images from scratch. Okay. Next, behavioral design patterns. So, behavioral patterns focus on communication between objects, how they interact, and how responsibilities are distributed among them. Some examples of behavioral design patterns are observer, strategy, command, chain of responsibility, mediator, template, iterator. Hmm. So, if I have to quickly talk about them as well, observer design pattern defines a one-to-many dependency between objects. So, when one object changes state, all its dependents are notified and updated automatically. For example, a weather monitoring system where various display devices like temperature, humidity update automatically when new data is received. Strategy design pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. The algorithm can be selected at runtime. For example, a sorting application that can use different sorting algorithms depending on the size of data or the requirement. Hmm? Uh, Command design pattern encapsulates a request as an object, thereby allowing parameterization of clients with queues, requests, and operations. So I'm not going to talk into more detail about other design patterns because I have already created one separate video for each of these design patterns where I have explained the design patterns in detail. Okay, so please go and watch it. And structural design patterns deal with object composition or the structure of classes, ensuring that the components of a system work together effectively and can be extended without modifying existing code. Some examples are adapter design pattern, decorator, facade, composite, bridge design pattern, right? So yeah, please go and watch those videos if you have not watched them. uh, Ideally this video should have been made first, and after this other video should be there, but anyway, in the playlist its position will be at the top, so anybody who comes from now onwards will watch this video first and then watch the other videos. Okay, so yeah, I'm sorry for the timing of placing this video, but yeah, I realized it late, but yeah, what else can I say? It is what it is now. So yeah, please watch the other videos on design patterns. I hope you will like it. Okay, so if we talk about their implementation, so design patterns are often implemented through classes and interfaces in OOPS, object-oriented programming languages. The structure of the pattern provides a blueprint for solving specific problems. Design patterns are documented with examples, explanations, and diagrams that illustrate their use and implementation. Okay. Now let's talk about the advantages of design patterns. Hmm? So first is reusability. Uh, Design patterns provide proven solutions that can be reused across different projects, thus saving time and effort. Hmm? Next is maintainability. Using well-known design patterns improves code readability and makes it easier to maintain and extend. Next is scalability. Design patterns help design scalable systems by promoting best practices and avoiding common pitfalls. And next is communication. Design patterns provide a common vocabulary for developers to discuss design issues and solutions effectively. But design patterns are also not free of challenges. They come with their own set of challenges, and let's see what they are. So, first is overuse, which is a very common problem. Applying design patterns indiscriminately can lead to over engineering and unnecessary complexity. So, we should be very clear where to use design pattern and what design pattern. It's possible that our like the place where we are introducing design pattern does not even need that, right? So we need to be very careful about that. Next is learning curve. So understanding and correctly implementing design patterns requires experience and knowledge of the context in which they are used. And context specific. Design patterns may not fit every scenario perfectly and should be adapted to the specific needs and constraints of the project. Okay, so this was all that I wanted to talk about design patterns. I hope this gave you a good idea about why you are studying design patterns. Like the remaining, I believe, some 25-30 videos in this playlist. Now after watching this one, you will have a clear idea of, okay, why each design pattern is there, what problem is it going to solve. Okay, so if you watch those videos with this curiosity that, okay, let's try to find out what this design pattern, what the next design pattern is going to solve, then I believe you will have more fun understanding it, and you will retain it for a much longer period of time. Okay, so yeah, that's all I wanted to talk about here. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.